Okay, so hopefully you didn't have too much difficulty in forming three separate tables or two separate tables, and then combining these two with the one we did together and getting one big table. So one way of creating a table that shows the strongest oxidizing agents and the strongest reducing agent is from these charts. Why are we making these tables? Because then if we wanted to know if a reaction was spontaneous, we wouldn't have to experimentally go do it. We wouldn't have to go find a piece of gold or silver and drop it into a solution of lead nitrate and hope that it doesn't blow up in our faces. Instead, we could look at the chart and say, oh, look, the oxidizing agent's on top, reducing agent's on the bottom. It's going to be spontaneous. I don't need to actually test it out. I can verify it on the chart. So this is one way of building a chart, but there's another way. Okay, so if you flip over, I think it's on the back side of the page we were working on, it says a second way to create a table. Okay, and it's still from experimental findings, it's just shown in a different way. So the experimental findings can also be represented in equations as follows. So you'll see we have equations here. Now, if the products are written out, then it's telling you it's spontaneous. If it says no evidence of reaction, then it means it's non-spontaneous. So experimentally, we've added these things in together, and then this is what we see as the products. So if we actually get these things out, then and we write them down, it's spontaneous. If nothing happens, then it's telling us that it's non-spontaneous. So to get our chart from these, first step is ask which is oxidizing and which is the reducing agent in the example. So if we look up here at this we have 3 CO2 positive and 2 IN, okay? The CO2 positive is going to CO solid. So it's gaining electrons because it's going from 2 positive to 0. And if it's gaining electrons, it means it's being reduced. And if it's being reduced, it means it's the oxidizing agent, right? Because things that are reduced are the oxidizing agent, things that are oxidized are the reducing agent. So if we look at the IN, it's solid, and so therefore oxidation number of 0, going to 3 positive, so it's losing electrons. If it's losing electrons, it means it's being oxidized. If it's being oxidized, it means it's the reducing agent. So step 1, ask which is the oxidizing and which is the reducing agent. For the first one, done. Step 2, ask is it spontaneous or not. This one is. So then, write one above the other in the appropriate order based on the answers to 1 and 2. So what that means is, remember, if it's spontaneous, it means the one that's the oxidizing agent has to come in the chart above the one that's a reducing agent. So the CO2 positive is the oxidizing agent. So it goes here, CO2 positive, going to CO solid, and this is aqueous. Notice that I dropped the 3's because I don't need them, they're in both spots, and I have to add 2 electrons here. And then because it's spontaneous, the IN is going to go below it because in a spontaneous reaction, the RA is below. So below it down here, and this is RA, so it goes on this side of the chart, will be IN solid. And over here will be IN3 positive aqueous. And again, I dropped those leading 2's because it has to be reduced. And I need to add 3 electrons in here. Okay, so I've started my chart. Now I go to the next reaction. The next reaction is copper ion and CO solid. So 2 positive going to 0. It's gaining electrons. And if it's gaining electrons, then it must be being reduced. And if it's being reduced, it means it's the oxidizing agent. And the CO is going from solid to 2 positive, 0 to 2 positive, so it's losing electrons, and so it must be Ra. Okay? And so, again, the reactants are written, or the products are written, which means it's spontaneous, which means the Cu must be above the CO in the table. So the CO is right here. I need to write the Cu2 positive aqueous above it, plus 2 electrons going to Cu solid. And then I don't have to rewrite the CO. It's already here, right? It's below it, so it's done. So now I can go to the third one. The third one is Cu2 positive aqueous and PD solid. It's telling us it's no evidence of reaction. But if it did react, it would go to Cu solid and PD. And if I look up on the chart, the PD is 2 positive, it forms 2 positive aqueous. Okay? And so it's non-spontaneous. Well, the Cu2 positive going to Cu solid, this is going to be the OA again because it's being reduced. This will be the Ra. And this time, because it's non-spontaneous, the Ra has to go above the OA. So the and that's good, because if it went below, where would it go below? So it has to go above. So up here, this will be PD solid. And over here will be PD2 positive aqueous plus 2 electrons. And I've now just formed a table, just like I did with the other chart, with the strongest reducing agent down here on the bottom, with the strongest oxidizing agent up here, and this is the second way I can form my chart. So I'd also like you to try, let's say 1 to 2, because these ones are a little tougher, so they might mess you up, but at least we'll have a start for Monday. Okay? Thanks, and enjoy the rest of your weekend.